Hello everyone. In this lesson video, we're going to talk about quadratic function, which is the type of function that you have seen before in this class. In the textbook, like you can see this introduction paragraph about quadratic function. One of the application that it talks about is the curved antenna, such as the one that I show here. They are commonly used to focus microwave and radio waves to transmit television and telephone signal, as well as satellite and spacecraft communication. When you look at the cross section of the antenna, it is in the shape of a parabola, which can be described by a quadratic function. And this has to do with one of the geometric property of the vertices of a parabola, which is something that we're gonna discuss in chapter, I believe it's in chapter 8 of this class. Sometimes quadratic function also model revenue or profit function in business. They also use to model problem involving area and projectile motion. So there's a variety of application that require quadratic formula. Now, working with quadratic function can be, oh, by the way, sorry, I misspoke with quadratic function, not quadratic formula. Because most of us know the quadratic formula is the formula for solving a quadratic equation, okay? And quadratic function is a type of function. Usually we know it by the form ax squared plus bx plus c. Now, when we work with quadratic function, it usually it's not as complex as any higher degree function, for example, like the cubic function or the 4-degree function. We're gonna study this function in depth, this type of function in depth, because it's actually not super complex as some of the function that we're gonna explore for this chapter, which is we're gonna focus on polynomial function in this chapter. And the higher the degree of the function, the complex the function, the more complex the function could get. So we all know the shape of a quadratic function. We all seen this. So let me just give you a sketch here. So let's say we could have a quadratic function look like this. So it could open up, right? This is a parabola that is open up. Or you could say open upward. And the function, so let's say the form of the function is f of x is equal to ax squared plus bx plus c. So this is the general form, okay? General form of the quadratic function. Now, when it opened up like this, the coefficient a is greater than 0. Okay, so a is greater than 0. And we have a vertex here. We have a vertex at this point. This is called the vertex. Now, the quadratic function that I sketched here has x-intercept and y-intercept as well, but that doesn't have to be the x-intercept. Sometimes a quadratic function does not have any x-intercept. Okay. Now, similarly, we could have a parabola that open down. So let's say we could have something open down like this. And in this case, the coefficient A is less than 0. Now, of course, here we assume that the A is not equal to 0, because if the A is equal to 0, then it's no longer a quadratic function, right? So here A is not equal to 0, because if A equal to 0, then the x squared term will be 0, which will turn it into a linear function. So here's the vertex here as well. So now for the vertex, we could actually figure out what the formula for the vertex is in this form. So the vertex happen to have this formula. So the vertex, let's see how you find the vertex. If you have the function written in the general form ax squared plus bx plus c, then the formula for the vertex is going to be this. So the x coordinate, you can find the x coordinate by taking the value b over 2a and then take the opposite of it. So it's negative b over 2a. Okay. Now, once you get the x coordinate, to figure out the y coordinate, you just have to plug in this negative b over 2a into the function. So it's going to be f of negative b over 2a. Okay, so this is how you figure out the vertex. If you have the function written in the form ax squared plus bx plus c, which is the general form for a quadratic function. Now you might be wondering, well, how do we get this negative b over 2a for the x coordinate? Well, it's had to do with the x coordinate for the vertex has a special property, and this special property is that there's a line of symmetry for the parabola that passing through the vertex. Okay, so here, let me draw the line of symmetry here for you. So this is what we call the line of symmetry. Okay, so this is the line of symmetry. Okay. So this line of symmetry is where the parabola have that the parabola is symmetric with respect to this line. Because imagine if you can form this parabola over the line of symmetry, they would fit exactly on top of each other. Okay, so this line of symmetry has an equation. It passing through the x-axis. It's a vertical line, and it's passing through the x-axis at a specific point. And at this point, the x value is actually negative b over 2a. So the equation for this line of symmetry is x equal to negative b over 2a. Okay, so one way that we can figure out this negative b over 2a is the fact that the x coordinate here at the line of symmetry is equal to halfway of the solution to the quadratic equation ax squared plus bx plus c equal to 0. So if you remember, if I have to solve the equations ax squared plus bx plus c equal to 0, I can use the quadratic formula. X is negative b plus or minus square root of b squared minus 4ac over 2a. So these are the two solutions to the quadratic equation ax squared plus bx plus c equal to 0. Now, if there is a x intercept for for the quadratic function that we're working with, then there would be two solutions. There would be two solutions, and you could actually see that the x coordinate of the vertex is exactly halfway between the x-intercept. Right, so you see how I label the x-intercept here. The x coordinate, the negative b over 2a of the vertex is exactly halfway between the two x-intercept here. So if you can find the two solution to the equation ax squared plus bx plus c equal to 0, and then find halfway between these 2 points, and halfway is at the midpoint, which is something that we learned before. Then you could then you can figure out that what is the x coordinate of that midpoint. Okay, and that midpoint happened to be the x coordinate of it happened to be negative b over 2a. If you do the calculation, you get that answer, and that will be the x coordinate for the vertex. Okay. Now let's do an example with this formula. Okay, with a formula for finding the vertex. So we could have so here is an example. Let's say find the vertex of f of x is equal to x squared minus 3x plus 5. So here, the x coordinate of the vertex it is equal to negative b over 2a. So negative b, so b in this case, see the a is 1 and the b is equal to negative 3. So negative b, you would have negative of negative 3 over 2 times a, so 2 times 1, and that's going to give us 3 over 2. Okay, x coordinate, and then the y coordinate of the vertex. So the y value is going to be equal to f of negative b over 2a. Well, that makes sense because, I mean, to find the y or the output value of a function, you just input the x. Now, I already have the input at the vertex, which is 3 over 2. Then to find the output, I just plug in that 3 over 2. Okay, so this is f of 3 over 2. And that's going to be 3 over 2 square minus 3 times 3 over 2 plus 5. So what is this going to be? So I have 9 over 4 subtract 9 over 2 and then plus 5. So I think I can get the common denominator to be 4. So this would be 9 over 4 subtracting 18 over 4. So that's give me negative 9 over 4. And then the 5, if I get a common denominator of 4, that would turn into, excuse me, that would turn into 20 over 4. So negative 9 plus 20, that's going to give me 11 over 4. Okay, so then the vertex would be 3 over 2, 11 over 4. Okay, so let's quickly verify this by graphing this. Now I'm not we certainly can graph this by hand, okay, but which we're gonna do soon in this section. But here I do want to just use decimal quick to sketch this. So y equal to, I could do f of x equal to x squared minus 3x plus 5, and point to the vertex there, 1.5 comma 2.75, Yeah, 1.5 is 3 over 2, and the 11 over 4 is 2.75. If you don't trust me, you could actually put in the point here, like 3 over 2, comma 11 over 4. Label it on there. You can see that. That's where the vertex is. Okay. Which is also where the line of symmetry is. So maybe we should mention that. I should have asked you to do that as well, I guess. So the line of symmetry is line of symmetry for this vertex is going to be x equal to negative b over 2a, which is equal to 3 over 2. So the line of symmetry x equal to 3 over 2. Okay. And we could sketch that on here too. You will see that, you know, if I put in the equation x equal to 3 over 2, see that line of symmetry there? Is the line that passing through the vertex. It's a vertical line that passing through the vertex. And the parabola is symmetric with respect to this line. Okay. Okay, so this is one form of this is what we call the general form of the quadratic function. But quadratic function also has another form, which is called the vertex form. Okay, so let's talk about the vertex form of a quadratic function. So the vertex form of the quadratic function is we would have to get the vertex form, we would have to we would have to complete the square in order to put it in vertex form. Okay, so the form of it would look like this. So we would have f of x is equal to a times x minus h being square plus k. So if a quadratic function is written in this form, then we can identify the vertex right away. So the vertex in this case will be h comma k. Okay, so that's the vertex form of the quadratic function. Now, let's say if I give you okay, let me give you an example. So here, say that f of x equal to the quantity x minus 3 square and then subtract 9. We want to identify the vertex x and y intercept. And axis of symmetry. So to identify the vertex, you identify well what h is. So h here in this case is equal to 3. Okay, but what's the k? The k is negative 9 because you see the plus k. So in this case, this k is equal to negative 9. So the vertex is 3 comma negative 9. Okay. Now the y-intercept is easier to find because you just plug in x equal to 0. So I'm going to do that first. So let's find the y-intercept. So we're going to set x equal to 0. And solve for y. So we would have, well, solve for y. Well, in this case, I guess I want to say n. So f of 0. So we would have, what is this? So we have f of 0 is going to be 0 minus 3, and this quantity being square, and then subtract 9. So that's give me 0. Okay, so that's give me 0. So the y-intercept I obtain here would be 0, 0. So the parabola would pass through the origin. Now for the x-intercept, I would have to set the function equal to 0, right? And then solve the equation for x. So that would give me x minus 3, this is being square, subtract 9 equal to 0. Well, this is in a form that where I can move the 9 over and use the square root property. So take the square root on both sides, get plus or minus square root of 9. And well, actually plus or that would turn into 3, right? So x minus 3 is plus or minus 3. So I have two equations here. This means x minus 3 is 3, or x minus 3 is equal to negative 3. So there are two equations that I'm going to solve. And if I move the negative 3 over, I would get x is 6, or x is equal to negative 3 plus 3 would be 0. Okay, so I have two x-intercept here. So the x-intercept would be one at the origin, 0, 0, and the other one would be at 6, 0. Now, clearly, the line of symmetry or the axis of symmetry, I guess I should have called it the axis of symmetry, because that's the term the textbook use, is where the vertex is. It's where the where's the x coordinate of the vertex, which is x equal to 3. Okay. Now, if you have the x-intercept, y-intercept, and the vertex, certainly you could sketch the graph of this function easily. So for example, here, let me find. So we have our vertex was it 3 and negative 3, negative 9. So I think I want to move this up a little bit just to make it easier. So let's say if negative 9 is here, and then let's say if this is, say this is 3. Okay. So this would be where the vertex is. And this 3 would be halfway between the two x-intercepts. So this is where the 0 is, the origin, and then on this side, this would be 6 over here. And then we can kind of sketch it, try to make it symmetric like that. Okay, so that would be the graph of this function. Okay. So you can see the axis of symmetry is this line. And this is the axis of symmetry. X is equal to 3. And it's passed through the vertex. Okay, so this is the vertex here. With the coordinate for the vertex is 3, -9. Okay, so let's see, we could do let's do another example where we try to write the equation. I mean, not write the function in vertex form. So vertex form sometimes is also called standard form, and then identify the vertex, x and y intercept, and the axis of symmetry as well. So here, the next example is write this equation, this function f of x equal to negative 2x squared plus 3x minus 7 in vertex form. So this vertex form is also called the standard form as well, standard form. And then we're going to, after we do that, we're going to identify the vertex x, y intercept. If there any, because sometimes there's no x-intercept at all. Of course, there's going to be a y-intercept, but the x-intercept, you might not have the x-intercept if you remember the term, the discriminant, which is the quantity b squared minus 4ac. If that quantity is less than 0, then there would be no x-intercept. X, y-intercept. And axis of symmetry. Okay, so in order to write a function in vertex form, we're going to use the technique of completing the square, and this is something that I showed you before when we were solving quadratic equation. So this is kind of similar to that. So the procedure is you just have to make sure that when you complete in the square, the coefficient on the x square has to be 1. And okay, so here the coefficient is -2, so we're gonna have to factor out the -2. Okay, so we're gonna start. So we're going to use the technique of completing the square. Completing the square technique. To rewrite f of x in vertex form. Okay, so we would have, so first I'm going to have to factor out the -2. So I would have f of x is equal to, factor out -2, and I would have x squared plus, well, because the negative is out, so this is going to be -3/2x. And because when you factor out the -2, that's the same thing as dividing every term here by -2. So the +3, when you divide by -2, that would give you -3/2. So that's why it turned into -3/2x, and then plus 7/2. Oh, actually, maybe I should. I'm going to. Oh, think we should just leave the 7 outside, okay? Because remember, we usually we would have to add a number here. We would add a number, an unknown number, and then I'm gonna leave the 7 out. So as it work with the two the term with x on it. Okay. So here we still have the subtract 7. Okay. And then what do we add here? We're going to add the square of the middle term, which is a 3/2, half of that. Okay, so if you remember, we would take this. So let me write this aside work here. You would do b/2, and then you square that. So b in this case is 3/2. So it's going to be 3/2, and then you divide by 2, and then you take this expression, you square. Okay, so that's going to give us that's going to be 3/4 square. So that's going to give us 9/16. Okay, so here I would have this is going to be equal to -2 times x squared minus 3/2 x plus, well, maybe I should plus 9/16. Okay. And then because we adding 9/16, we're gonna have to subtract that 9/16 as well. Okay, so I'm gonna write subtract 9/16 there. Just to make sure that the whole, we're not changing anything. There's, it's when you add 9/16 and you subtract 9/16, that means you're adding 0. Okay, so we're not changing the function at all. Okay. Okay, so now what? Now these 3 terms here, that's a perfect square trinomial, because when we complete the square, that would give us a perfect square trinomial. So now I need to bring the -9/16 outside of the parenthesis, and I just have to make sure that I multiply it by -2, because there's a -2 that get multiplied to every term inside the parenthesis. Okay, so when I take -2 times -9/16, that become a plus. Okay, so this is actually, this is going to be -2 times x squared minus 3/2x plus 9/16, and then the -2 multiplied by the -9/16 would give me 18/16, and if I reduce that, that would give me 9/8, and that's going to be positive. So plus 9/8, and then subtract 7 will stay. Okay. So hopefully you can follow that. I got the 9/8 because I take -2 times -9/16. Okay, and that's giving me the 9/8. Okay, now the perfect square trinomial will turn into this. This is gonna be x minus 3/4 square. Okay, and then 9/8 subtract 7. I would have to get a common denominator of a. So the 7 would turn into 56/8. Give us 7, right? So 9/8 subtract 7 is 9/8 subtract 56/8. Well, 9 subtract 56 would give me -47/8. Okay, so that's going to be -47/8. So then this is in vertex form. All right, there's a vertex form of the equation. So this is the vertex form of the quadratic function. Now you might be wondering, what's the point of doing this if we can just find the vertex by taking negative b over 2a to get the x coordinate and then just plug in that value into the function in order to get the y coordinate of the vertex. Yes, you can always find the vertex that way. Okay. Here the question is not about that finding the vertex. The question is to check whether are you able to convert between the different form of the quadratic function, the general form ax squared plus bx plus c, and then convert it into the vertex form, okay, and vice versa. Okay. So here, based on this, we could identify the vertex, because let me remind you that the vertex form would look like this. It would be f of x is equal to a times x minus h. That quantity x minus h is being square and then plus k. Okay, so we're going to identify what is the h, what's the k in our function. So h here, h is going to be 3 over 4, and the k is going to be negative 47 over 8. Okay, so then the vertex for this parabola is going to be 3, 4, comma, negative 47 over 8. Okay, and of course, when we're done with this, we're going to try to verify it by plotting this on decimal as well. So we get the vertex. What else do we have to do? We have to find the x and y intercept and the axis of symmetry. Well, once you get the vertex, you can figure out the axis of symmetry right away, because it's just going to be x equal to the x coordinate of the vertex. So the axis of symmetry is going to be x equal to 3 over 4. Now let's find the y-intercept first, which means we need to figure out, well, what is f of 0? So f of 0 is, we're going to plug in 0 into the equation. And I think it's easier if you plug into the original function. So that's going to give us negative 2 times the square of 0. And then I think it's plus 3 times 0 minus 7. So that gives us negative 7. So the y-intercept is 0, negative 7. So there's a y-intercept there. Now to get the x-intercept, we're gonna set the function equal to 0. So we have negative 2 times x squared plus 3x minus 7 equal to 0. Okay, so first, you might want to check if this is factorable. So if I take negative 2 times negative 7 is positive 14, and then this is 3. No, I cannot find any number where their product is 14 and their sum is 3. So this is not factorable, which means we would have to use a quadratic formula for this. So x is going to be negative b plus or minus the square root of the quantity b squared minus 4ac over the quantity 2 times a. Okay. So this is going to be negative 3. And then the square root of 3 squared minus 4 times negative 2 times negative 7 over 2 times negative 2. So x is negative 3 plus or minus the square root of, it's going to be 9 subtract 56. 9 subtract 56, how much is that? Negative 47 over negative 4. Now, because the radicand, which is the number inside the square root, is a negative value, which means that there is no real solution. Okay, so this is this solution is not a real number, is not a real solution. And if it's not a real solution, that means there's no x-intercept, because the x-intercept has to be a real number. Okay, but here this is not a real number. So this tells us that the parabola, the graph of this function, which is a parabola, it does not intersect the x-axis at all. Okay, so no x-intercept. Okay, I think that's pretty much everything for this problem. Now let's quickly sketch this on Desmo, just to verify this. And in fact, I believe I can sketch this here too. Let me see here. Okay. Graph in 2D. Oops. I'm not sure why it's not graphing, because I was. Okay, anyway, let me. Because it's supposed to. The OneNote software has a map packet that is, it should be able to draft that function. Maybe let me see here. Anyway, I don't want to waste your time with this, so let me see this. See, that's the draft of the function here, and you can see that there's no x-intercept, right? Because the value, the coefficient a is negative, that's why it's open downward, and we could actually put in the coordinate for the vertex, which we found was 3, 4, comma, I believe it was negative 47 over 8. But yeah, that's the vertex there. So it's what we, okay. Okay, so let's move on. Let's try a different type of question. So you can see that based on the graph of a parabola, we able to identify where the the maximum and the minimum of the quadratic function, because if you have a parabola that open up, so if the parabola open up, then at the vertex, the y value would be the minimum of the function, and it would be a local minimum, and it's happened to be the absolute minimum as well. And then if the parabola parabola open down, then you would have at the vertex you would have a local maximum, and also it's also that local maximum is also the absolute maximum as well. So let's see. Let's do an example that involving maximum and minimum. Okay, so imagine if you have a parabola. Let's say if this is a parabola, it's open up, right? If it's open up, that means the coefficient a is greater than 0. And here, assume that this function f of x equal to ax squared plus bx plus c. So at the vertex of this point here, we would have a maximum. So the maximum happened at the vertex. I mean, we would have a minimum because that's the lowest point on the graph of this parabola, right? So it's because it's happened at the vertex, and you know the coordinate for the vertex is negative b over 2a, comma f of b over 2a. And when we talk about maximum or minimum value, that is the y value. Okay, so so we will say that, you know, if the parabola open up like this, the minimum value so would happen at would be f of b over 2a, f of negative b over 2a. Sorry. So let's see. So we're going to say that if the parabola open up, which means that a is greater than 0, then f of negative b over 2a is the maximum value. I mean, is the minimum value. Sorry, is the minimum value, which is, you know, the lowest point, because it's happened the lowest point on the parabola that opened up happened at the vertex. Is the minimum value of f from the lowest point, right? The lowest point on the graph. Okay. Now, similarly, we could have, you know, we could have a parabola that opened down. So our parabola could have gone like this. And then at this point, at the vertex, so here we would have the coefficient a would be less than 0. So we're going to say that if the parabola open down, which is when a is less than 0, then the function evaluate at negative b over 2a, which is where the x coordinate of the vertex is, would be the maximum value of the function f. Now, knowing this is useful because when we work with optimization problem, which is the type of problem where you try to figure out where's the maximum value or the minimum value of a function is, and if you encounter a quadratic function, then it's easy. It's because you can just, if you have a quadratic function, you can identify the vertex and the maximum value or the minimum value will be achieved at the vertex. Okay, so let's do an example with this. So example, we're gonna determine if the equation, the function, the quadratic function has a maximum or minimum value, and then find the maximum or minimum value. Okay. So this function f of x is equal to 2x squared plus 12x minus 3. Well, to know whether it has a maximum or minimum value, we need to figure out whether it's open up or open down. And to figure out whether it's open up or open down, we have to identify the coefficient a. So a in this case is 2, which is positive. And if a is positive, the parabola open up. So if the parabola open up, that means there will be a minimum. So there is a minimum. Okay. So to find the minimum value, we're gonna evaluate f of negative b over 2a. So first, I want to figure out, well, what is x equal to negative b over 2a, which is the x coordinate of the vertex. Okay. So this is going to be negative 12 over 2 times a, so 2 times 2. So this gives me negative 3. Okay, so then let's evaluate f of negative 3. Okay, so here we have 9 times 2 is 18. 18 subtract 36 would give me negative 18, and then minus 3 would be negative 21. Okay, so we have answered that the minimum value is negative 21. F is f of negative 3, which is equal to negative 21. Okay. So we also talk about the interval on which the function is increasing or decreasing before. So we could do an example with that for quadratic function. And for quadratic function, you can see that there's only two kind of behavior. which is, so if, let's say if I have, if this x, this is y, and I have, this is my function. Okay, if it's open up like this, and at this point here, where the vertex is, so this is going to be negative b over 2a, comma f of negative b over 2a. So assume that my function look like this: f of x equal to ax squared plus bx plus c, and we don't want the a to be 0. So the behavior of this quadratic function is that from negative infinitive to negative b over 2a, you can see that the function is head the shape of this kind of way. So it's going down. So as the x value getting larger, the y value would be getting smaller on that interval from negative infinity to negative b over 2a. So right here, at this point right here, the x value here is negative b over 2a. But then on the other side, on the right hand side of negative b over 2a, the function would have this kind of shape here. Okay, so that means it's increasing. So on this side it's decreasing on this side, and then on this side is increasing. And let me remind you that a function is increasing if the x value increase, then the y value also increase, the output also increase. And now a function is decreasing if the x value increase and the y value decrease. Okay. So based on this, you can see that this function would be decreasing on the interval from negative infinity to negative b over 2a, and it is increasing on the interval from negative b over 2a to positive infinity. Okay. Now the opposite would happen if we have a parabola that open down. Okay, so this is when a is greater than 0. That's why it's open up. Now if it's open down, okay, so let's see. Let's say if it's something like this. Oops. Let me make it a little bit nicer. How about on this side? So here is, let's see, negative b over 2a there. And again, we have the function is f of x equal to ax squared plus bx plus c, written in the general form. Okay. So this time, you see on the left-hand side of of x equal to negative b over 2a, the function would have this type of shape here, where it's rising up from left to right. And then on the right-hand side, the function is falling down from left to right. So on this side, the function would be increasing, and it's decreasing on this side. Okay. So when you take when you get to calculus, you learn that we have a name for the point where the function change its behavior from increasing to decreasing or decreasing to increasing, and set a point is called a critical point. So there's a critical point here at x equal to negative b over 2a. So here, in this example, so this for a less than 0, when it's open down, the interval where it's is decreasing. Oops. would be from negative b over 2a to positive infinity, and this is increasing on the interval from negative infinity to negative b over 2a. Now, clearly, you shouldn't have to memorize this. Don't memorize this, okay? But you just have to sketch the graph of the, well, actually, you don't even have to sketch the graph of the function, because you can kind of visualize it if you know whether it's open up or open down by identifying the coefficient a, and and then compare the coefficient a to see whether it's positive or negative. Then from there you determine whether the parabola open up or down, and then from there you should be able to identify the vertex, and that will help you determine where the function is increasing and decreasing, because at the vertex, where at the x coordinate of the vertex is where the function change its behavior. Okay, so we could do an example with this. Yeah, we're going to so that f of x equal to 2x squared plus x plus 1. So we're going to find the vertex axis of symmetry x and y intercept. So I'm just going to say intercept, okay? So there's and by intercept, I mean both x and y intercept. And then graph f of x. And then for proxy, find the domain and range. And then the last part is determine where f is increasing or decreasing. Okay. So for well, the question doesn't ask us to convert this function to vertex form, so I'm just gonna leave it in this form, okay? And then figure out the vertex by using the formula x equal to negative b over 2a. Okay, so we would have so for a, we're gonna have x is negative b over well, maybe let me rewrite just so the vertex, it would be negative b over 2a for the x coordinate, and the y coordinate would be set f of that value. Okay, so let's figure out negative b over 2a. So that would be negative 1 over 2 times 2. So that's negative 1, 4. Okay. Now the y value, which is the f of negative b over 2a, which is f of negative 1, 4. Okay, so let's see what this is. So you take 1, what is 1, 4 square would be 1 over 16 times 2. So that would give us 1a. And then subtract 1, 4, that's give us negative -1/8 and +1. So that's going to be 7/8. Okay. So the vertex for this quadratic function is that -1, 4, 7/8. Well, based on this, I can figure out the axis of symmetry right away. So that's going to be x is equal to -1, 4. Okay. Now let's find the intercept for this. I'm going to find the y-intercept first. So I would be evaluating f of 0. And that's going to be, let me see here. It's 2x squared plus x plus 1. 2 times the square of 0 plus 0 plus 1. So that's give me 1. So the y-intercept is 0, 1. Now if we do let's solve for the x-intercept, I would get f of x equal to 0. So we have 2x squared plus x plus 1 equal to 0. Let's see. 2, 1. This is not factorable. It's not factorable, so we're going to use the quadratic formula on this. So we're going to have x is -1 plus or minus the square root of 1 squared minus 4 times 2 times 1 divided by 2 times 2. And I can see that, excuse me, the radicand is going to be a negative number. Would mean that this is not a real solution, so there's no x-intercept. Okay. So this give me x is -1 plus or minus the square root of -7, which is a problem. Right? So this is not a real solution. So that means there's no x-intercept. Okay, so let's see if does that take care of part A. Yeah, that's part A. Now for part B, we want to graph the f of x. Well, so far we only have the vertex. We have what else? We also have the y-intercept. So let's try that. So let's try to locate this. So let's see if we could. Well, I want to. I want to insert. Let's see here. Oops. Okay. So I want to put this coordinate system on here. And what I want to use is to sketch this. Let me try to move this. Okay, so please ignore this b equal to 1, whatever it is. That shouldn't be there. Okay. Okay, so here I'm going to do this, the scale by this. So let's say this is 1, let's say 2, negative 1, let's say negative 2. So 1, 2, negative 1, negative 2. Okay. So I'm going to locate the y-intercept 0, 1. So 0, 1 would be this point here. And then I'm going to also identify the vertex is at negative 1, 4, 7 over a. So 7 over a is close to 1. Negative 1, 4 would be a quarter of 1. So that would be right here. And 7 over a. So it should be somewhere here. Okay. So remember, if we have the axis of symmetry, it would go to the axis of symmetry. The axis of symmetry would go to the vertex right here. Okay. So I can use the axis of symmetry and the vertex and the point, the y-intercept, to figure out the third point, because there must be a symmetry over the axis of symmetry. So another point on the graph would be this one right here. Okay, it would be at the an additional point that's on the graph would be the value for it would be negative 1/2 1. I didn't even plug in anything. I just use the symmetry, and the symmetry tell me that, well, because there is symmetry over the axis of symmetry, and the axis of symmetry is x equal to negative 1 over 4, and this line here that I draw. Then I, based on the graph that what I draw, what I have, which is the 2 point that I have here is negative 1 over 4 comma 7 over a, which is where the vertex is. And then the other additional point that I have is 0 comma 1. Then I figure out that the point on the left of the axis symmetry would have to be negative 1/2. Oops, negative 1/2 comma 1. Because the vertex would be the point in the middle. Okay. So then I can sketch this. I can sketch this parabola passing through these 3 points. Now, certainly you don't have to, do it the way that I just show you, because what you can do is you can just make a table with x and f of x, because we only have 2 points already. You have 0, 1, and you have negative 1 over 4, 7 over 8. You can plug in any other point, like 1. You can plug in 1 and figure out well, what would be the y value for that? Let's say if I plug in 1, and I would get 2 plus 1 is 3 plus 1 is 4. So I get 4. Or I can plug in 1/2 or whatever number that you prefer to get a few additional points, and then from there sketch the graph of the function. Okay. Okay, so that would be part B. Now for C, we're going to find the domain and the range. So this is B. So the domain of a quadratic function is always on real number, right? So the domain D is going to be on real number, because for quadratic function, you can always plug in any value for x, and it's always produce a real number output. Your output is always a real number, so you don't have to worry about having an output that is undefined. Okay. Now for the range, this parabola is open up, so you're looking for the lowest y value, and then because there are two arrows that pointing up, that means the y values that keep getting larger and larger if the x value getting larger. So in this case, the range would be where the lowest y value would be happen at the vertex, which is the minimum for this function, and that is 7/8. So the range would be from 7/8 to positive infinity. Okay. Now the last part of this is determine where the function is increasing and where the function is decreasing. So we talked about this earlier. You can see that the function is open up. So, and you can look at on the left hand side of the vertex where the axis of symmetry is. The function is falling down from left to right on that on the left side of the vertex. So that means the function is decreasing. This function f of x is decreasing on negative infinity to where the x value of the vertex is, which is negative 1/4. Okay, so we would have this is decreasing on the interval from negative infinity to 7/8, sorry, negative 1/4. So when we're talking about the interval where the function is increasing or decreasing, this is on the x. Okay, this is negative 1/4, and then it's increasing on the interval from negative 1/4 to positive infinity, because you can see on that side of the parabola, the function has a shape of, the shape is going rising up, so it goes down like this, and then it's going up like that. Okay, so I think this should be enough on some of the properties of a quadratic function. In the next video, I'm going to go over some application problem with you where we use quadratic function. See you in the next video.